transformation designed to reduce fuel consumption, lower pollution, and improve energy efficiency. They are becoming increasingly popular because fossil fuels are limited and environmental concerns are growing. Then what is hybrid and electric vehicles? It's reduce greenhouse gas emissions, decrease depends on petroleum, improve energy efficiency, and support sustainable transportation. Then history of electric vehicle. Early electric vehicles were developed in the 19th century. Petrol vehicles are later become dominant due to better range and cheaper fuel. With climate change concerns and advancement in batteries, electric vehicles have become popular again. Governments worldwide now encourage EV adoption through subsidies and infrastructure. The types of electric vehicles: battery electric vehicles, BEVs, and runs entirely on electricity, no engine or fuel tank, zero tailpipe emissions. And hybrid electric vehicle that's use both an internal combustion engine and electric motor. Battery charges automatically while driving. Plug-in hybrid electric vehicle battery can be changed externally. Can operate in both electric and fuel modes. And fuel cell electric vehicle use hydrogen fuel cells to produce electricity, emits only water vapor. Then again, main components of electric vehicle, that is a battery pack stores electrical energy, usually lithium ion batteries, determines vehicle range. And the three types of main hybrid electric vehicles: one is series, and other one is series parallel, and another one is complex hybrid. Then electric motor, it converts electrical energy into mechanical motion, provides instant torque. Controller controls motor speed and torque, acts as the brain of the electric vehicle. The inverter converts DC battery power into AC for the motor, and the charger charges the battery from the electrical grid. Regenerative braking converts braking energy into electricity, improves the battery efficiency. And the hybrid vehicle working principle: a hybrid vehicle combines internal combustion engine, electric motor, then battery and power control unit. Operating models: electric mode, engine mode, and combined mode, regenerative braking mode. Benefits of hybrid electric vehicle: better fuel economy, lower emissions, longer driving range. And battery technology types: three types of battery technologies. One is a lithium ion battery, then nickel metal hydride, and last one is solid state batteries. Is a futuristic one of the important battery characteristics: capacity and energy density, charging time, battery life, and safety. Battery management system is monitors battery temperatures, prevents overcharging, balance battery cells. And the charging methods: level 1 charging is household outlet and slow charging. Then again, direct current fast charging. Level 2 is an home or public charger and faster charging. Then again, direct current fast charging, high power charging station, charges batteries quickly. And the advantages of electric vehicles: then zero tailpipe emissions, lower running cost, high efficiency and quiet operations, instant acceleration. And the disadvantages: high purchase price, limited charging stations, long charging time, battery degradation, limited driving range. Then future of electric vehicles: electric vehicles, solid state batteries, wireless charging, faster charging technologies, autonomous electric vehicle to grid, that means V2G technology, and the increased renewable energy integration. And the applications are passenger cars, electric buses, delivery vehicles, two-wheelers, trucks, and industrial vehicles. Then the classifications of electric vehicle based on degree of hybridization, mild and power energy, and then mechanical power transmission part. The first one is fuel into internal combustion engine and transmission and coupling drives. Another finally it's run the vehicles for this is a transmission path in conventional in IC engines, and the electrical power transmission path. First energy storage is, and then power is converted to electric machine and drive, and coupling devices finally go to vehicles. Power transmission path in electrical vehicle. Then combination of MPTP and EPTP. The propulsion power is transmitted to wheels through either MPTP or EPTP or combination of both. Is an IC engine and transmission where is consist of energy storage system, generator, propulsion motor, and transmission. This is a block diagram of hybrid electric vehicle powertrain and the series hybrid electric vehicle. A series hybrid is one of which only one energy converter and can provide propulsion power. Electric motor provides all propulsion power to wheels. Then IC engine drives a generator. The drawback is of traction motor which has to be rated for maximum power requirement of vehicle. This is a block diagram of series hybrid electric vehicle powertrain. Then series parallel series electric vehicle advantages is a flexibility of location of engine generator set, simplicity of drivetrain, suitable for short trips with the stop and go traffic. Disadvantages: it needs IC engine, generator, and motor, and the motor must be designed for maximum sustained power that vehicle requires, such as climbing a high gradient, and the maximum power of long distance high speed driving. A parallel hybrid electric vehicle. A parallel hybrid is one in which more than one energy conversion device and can deliver propulsion power to the wheels. IC engines and electric motor are configured in parallel with a mechanical coupling. The power requirements of electric motor is lower than that of series hybrid electric vehicle. And this is a block diagram of parallel hybrid electric vehicle powertrain. And the advantages of parallel hybrid electric vehicle: it needs only IC engine and motor and generator. A smaller engine and motor can be used to get same performance until battery are depleted. The disadvantages of complexity increases, and power flow has to be regulated blended from two parallel sources. Power blending from IC engine and motor needs a complex mechanical device. Series parallel hybrid electric vehicle, it is combines benefits of series and parallel architecture. The power split device divides the output from the engine into mechanical and electrical transmission paths. Even IC engine is also used to charge the battery. They are capable of providing continuous high output power compared to series and parallel powertrain. This is a block diagram of series parallel combination hybrid electric vehicle. And the drive modes of operation. This is a drive modes of operation. First one is electric only, and the second one is hybrid and electric assist, and third one is battery charging, and fourth one is regenerative braking. And torque characteristics. This is a speed and torque calculation, and the electric motor and IC engine torque characteristics for this graph, and the torque characteristics of motor shown along with the torque characteristics of IC engine. Electric motor, a high torque is available starting. The peak or rated power from a motor is obtained at base speed when motor characteristics enter the constant power region from constant torque region once voltage limit power of supply is reached. And the modes of operation: Toyota Prius car, this is for example. Then commercial vehicles, for example, for Toyota Prius, Toyota Highlander, Ford Escape, Mercury Mariner, Honda Insight, and Honda Civic hybrid electric vehicle, and Honda Accord hybrid electric vehicle. And this is a model for hybrid model and non-hybrid model. First one is Honda Accord Hybrid X, then second one is Honda Accord excel. The challenges for HEV, time battery charging is long battery or heavy. Batteries are expensive and low performance in hot or cold temperatures also may damage the battery. Very sensitive to overcharge and undercharge. Contain toxic heavy metals and disposal issue. Advantages of a hybrid car: environmental friendly, financially benefits, less depends on fossil fuels, regenerative braking system built from lighter material. Disadvantages of hybrid car: less power, expensive, poor handling, higher maintenance cost. Then global warming still an issue. Hybrids are less emission vehicles, will cut down emission of global warming pollutants from one third to a half. Later models may cut down this emission even more. Hybrid maintenance, this is normally warranties. The average warranties for hybrid now is around either 8 year 1 lakh miles or even 10 year. Brake parts no maintenance. Batteries $6,800 for new Toyota and Honda hybrid batteries tested to go for 18,000 miles and more. Then BMW Bright Idea is a new technology for it, has moved on to hybrid gas electric vehicle with the X3 SUV that features super capacitors instead of batteries to store energy. The super caps are safely designed so that in the case of an incident they get discharged immediately so as they avoid further possible damage. And the future scope, then types of hybridization, there is medium hybridization. These are the feature idle stop function, regenerative braking. Most are not capable of using electric motor alone to propel the vehicle. The electric motor usually assists the engine. Battery voltages are about 144 to 158 volts. Then full hybridization, these are the feature idle stop function, regenerative braking, the same procedure for hybridization. Batteries are most are capable using electric motor alone to propel the vehicle. Battery voltages are about 200 to 300 volts. Then this is a series hybrid, parallel hybrid, and the series parallel hybrid. This is next one is option is a complex hybrid vehicle. This also same for series and parallel hybrid vehicle. Then the part of a hybrid electric vehicle, engine part, it's much same as other vehicles engine, but the size of hybrid electric vehicle engine is small and it's more fuel efficient. There are two types of engine mostly used in hybrid electric vehicle. Always use the petrol engine or diesel engine. And the battery capable is three types of battery are using. One is a lead acid 2.2 voltage and nickel cadmium 1.2 voltage. Lithium ion is a 3.7 voltage. It stores the energy generated from gasoline engine or during regenerative braking from the electric motor. Then electric motor, most of the electric machines used in hybrid vehicles are brushless DC motors. This is a BLDC. It's power the vehicle at low speed and assist gasoline engine when additional power is needed. This is a controller of hybrid electric vehicle. The controller is used to charge the battery or to supply the power to electric motor. Can show amplitude, direct current or frequency, alternative current. Power is based on low voltage input 4 to 20 mega ampere or 0.5 voltage. Converts battery DC to a choke DC power. And the generator it converts mechanical energy from engine into electrical energy, which can be used by electric motor stored in the battery. It's also used to start the gasoline engine instantly. And this is our advantages and disadvantages of electric vehicle, hybrid electric vehicle. So need electric and hybrid vehicles. Need for electric and hybrid vehicles over depends on petrol and diesel. Raising petrol diesel prices, pollution and the resultant global warming, noise in conventional vehicles, need for alternate power source, need for eco-friendly electric vehicle and hybrid electric vehicle is the solution. Well, electric vehicles is an automobile that is propelled by one or more electric motor using electrical energy stored in energy storage device. The primary components are motor, controller, power source and transmission. This is block diagram of an electric vehicle system. And the concept of hybridization is a multiple sources of power, making IC internal combustion engine work in most efficient range. Sizing of motor and internal combustion engine lower compared to conventional vehicles and electric vehicle. The hybrid vehicles, the terms of hybrid vehicles in general usage refer to vehicles with 2 or 3 different types of sources delivering power to the wheels for propulsion. And the most common hybrid vehicles have an IC engine and one or more electric machines for vehicle propulsion. This is a classification of a hybrid electric vehicle based on the path of energy flow. First one is mechanical power transmission path. This is an MPTP. The EPT, the abbreviation of electric power transmission path. A combination of MPTP and EPTP based on architecture, series parallel and series parallel. Then futurist one is an complex. Then classifications based on degree of hybridization, mild power energy, charge depleting and charge sustaining. Mechanical power transmission, these are already power transmission path in conventional IC engine. Electrical power transmission path, in electrical power transmission is almost electrical except for coupling device between electric propulsion motor and wheels. The coupling device can simply be a gear to match electric machine speeds to vehicle speed. Combination of MPTP and EPTP, that propulsion power is transmitted to wheels through either MPTP or EPTP or combination of both. This is a black diagram of hybrid electric vehicle. Then the series is already being on. Of operation. It's a commercial vehicles nowadays. Most of electric vehicles using Honda and companies are Honda, then Morris Garage, then Ford, Toyota, Honda Insight. The models are Toyota Prius, Highlander, Escape, Mercury Mariner, Honda Insight, and Civic hybrid electric vehicle, Honda Accord hybrid electric vehicle. These are the models. Then challenges: times of battery changing is long, battery or heavy, batteries are expensive. The battery, BMW bright idea is nowadays using the BMW car. Then BMW has moved on to the hybrid gas electric vehicle with X3 SUV third that features super capacitors instead of batteries to energy store energy. Then these types are Tata hybrid product. This is nowadays using the higher end technology for principal component analysis, that is an PCA. It's a hybrid maintenance. This process is always hybrid maintenance. This one, the one part of that less power. The main disadvantages of hybrid car: less power, expensive, poor handling, and higher maintenance. Then what is HEV? That means HEV in a hybrid car is a car that uses both electricity and fuel injection in order to run. First one is the hybrid vehicle mean that a conventional process, that is fuel to engine and transmission to run the vehicle, and then second one is plus battery electric battery and the motor generator, and finally transmission to run the vehicle. To plus the hybrid electric vehicle, that conventional and battery electric is added to battery and fuel engine motor generator, then again completed to run the vehicle. Then the history of HEV is the 9th century already, I will tell. Then battery electric vehicle invented the Thomas Davenport and Robert Anderson others using non-rechargeable batteries. And then 1890s EVs are outsold gas cars 10 to 1 volts mobile, and Studebaker started as an electric vehicle company, companies 1904. Krieger companies builds first hybrid vehicle 1910s. Mass produced Ford cars and built electric vehicles. Electric vehicle persist as a status symbols, utility vehicles until Great Depression. Then mild and micro hybridization, the types are they are in idle stop function, regenerative braking, or are not capable of using the electric motor to propel the vehicle. These systems are usually 42 volts or less, and the medium hybridization, they feature ideal stop function, regenerative braking. Most are not capable of using electric motor alone to propel the vehicle. The electric motor usually assists the engine. Battery voltages are about 144 to 158 volts, and the full hybridization is an they feature ideal stop function, regenerative braking as the same as most are capable using electric motor alone to propel the vehicle. The electric motor also assists the engine. Battery voltages are about 200 to 300 volts, and the series parallel and the complex. The engine is much same as other vehicles engine, but the size of hybrid electric vehicle engine is small and it's more fuel efficient. One is an already I tell petrol engine and diesel engine. This is a battery and electric motor. Okay, that's all. The hybrid Tata's hybrid product conclusion: using the concept hybridization of cars results in better efficiency, also saves a lot of fuel in today's fuel deficit world. A hybrid gives a solution to all the problems to some extent. One can surely conclude the concept will follow with even better efficiency and conservation rate. Thank you.